Assalamualaikum dan salam sejahtera. I need to present the introduction of building foundation. The foundation of the building is the lowest part of the building that bears the entire load and distribute it to the earth. On like the dead load, that is the weight of the building, and the living burden like a human being, as well the wind load. The basic purpose of the building contain the overall load, and secondly, the prevent the building settling, and three, get a flat floor surfaces. Factor influencing the selection of building foundation is a physical condition of the soil, load bearing physical, building load, dead load, life load, and weight load. Lastly, and the cost. The basic type of the building. First, 1. Street foundation, 2. Pad foundation, 3. Pile foundation, and 4. Raft foundation. Of the building foundation is a reduction of the load intensity, even disruption of the load, prevention of level surface, protection against soil movement, lateral stability, safety against and determination of load intensity. Foundation distribute the load of the superstructure to a larger area so that the intensity of the load at its base does not exceed the safe bearing capacity of the subsoil. Distribution of load. Foundation distribute the non-uniform load of the superstructure evenly to the subsoil. Example, two column carrying unique load can have a combined footing which may transmit the load to subsoil evenly, while uniform soil pressure. C. Provision of level surface. Foundation provide leveled and hard surface over which the superstructure would.
Hi, Assalamualaikum. The next function of building foundations are lateral stability, safety against undermining, protection against soil movements. Lateral stability, it anchors the superstructure to the ground, thus imparting stability to the superstructure. The stability of building against siding and overturning due to horizontal force such as wind, earthquake, and etc. in increase due to foundations. Next, safety against undermining. It provides the structure safety against undermining or scoring due to burrowing animals and flood water. The lastly is protection against soil movements. Special foundation measures prevents or minimize the distress or cracks in the superstructure due to expansion or contraction of the subsoil because of moisture movement in some problematic soil. We have factors that contribute to the selection of the foundation: total loads of the building, nature and bearing capacity of soils, type structure in neighborhood, type of foundation, and level of water table. I will explain about total loads of the building. This load is combination of dead load and imposed loads in the buildings. Other loads such as wind load, earthquake loads, etc. are also considered based on location. The quantity of loads depends on the type of structure, number of flats, and material of construction. The next is nature and bearing capacity of soil. Okay, soil is a mixture of solid particles, moisture, and air. Soil can be of many types such as expansive soil, sandy soil, or loose soil. The soil investigation should be carried out to know the nature of soil and to know the bearing capacity of soil at different levels for large structure. When the loads is transferred from the structure to soil through foundations, the soil length to consolidate and settlement of foundation occurs. We go through to the soil investigation should be carried out for following information. The first, the nature and thickness of made-up ground and topsoil above the subsoil. Second, the nature, thickness and stratum depth of subsoil. Third, and assessment of allowable bearing pressure. The fourth, groundwater levels, chemicals in the ground. And lastly, existing structure in neighborhood.
Level of water table. A lower water table increase the effective pressure and might cause additional settlement. A rise water table may create problem for the owner from the following: floating the structure, reducing the effective pressure, creating a wet basement if the basement walls are hot water type. Type of fluid have 3 items. First, dead fluid. The weight of the building, which includes substructure, superstructure, and finishes. For example, walls, roof, floor, marbles. Second, live fluid. The weight of occupant furniture and other movable goods. For example, human being, animal, table, and chair. Third, wind load. The force which the wind blowing from any direction and will exert on the building. The positive and negative pressure exerted on a building when it obstructs flow on moving air. As you can see, this is a type of fluid or structure. You can see the negative wind load, the snow load, the live load, the positive wind load, hydrostatic pressure from water pressure in ground, and dead load. Type of foundation have 4 items. You see isolated foundation, combined footing, pipe foundation, and mat foundation or raft.
Good morning everyone, my name is Anita Nudai Anamurum. Want to talk about some the types of foundations, which is shallow foundations and deep foundations. This is some parts about shallow foundations, which is isolated spreads or individual footings. This is the most widely recognized and most straightforward shallow foundation type, as this is the most economical type. They are typically utilized for shallow establishment to convey and spread concentrated burnout causes, for instance, by pillar or columns. They are generally used for ordinary buildings. There are 6 types of spread footings: single pad footing, stepped footing for a column, sloped footing for a column, wall footing without steps, stepped footing for wall, and grillage foundations. To decide when to use shallow foundations, it is necessary to know when it is economical. It is economical when the load of the structure is relatively low. 2. Columns are not closely placed. 3. The bearing capacity of the soil is high at a shallow depth. Besides that, wall footing or straight footings is also known as continuous footings. This type is used to distribute load of structural or non-structural load-bearing walls to the ground in such a way that the load-bearing limits of the soil isn't outperformed. Okay, wall footing is economical when, first, load to be transmitted are small magnitudes. 2. It is placed on beams, sands, and gravel. Okay, now we move on to combined footing that was very similar to the isolated footings, which is constructed when 2 or more columns are close enough and their isolated footing overlap with each other. Combined footings is also economical when, first, the columns are placed close to each other. 2. When the column is close to the property line and the isolated footings will cross the property line or become eccentric. 3. Dimensions of one side of the footing are restricted to some lower value. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hanisa and I will continue this topic. Next, we have cantilever or strap footings. Strap footings are similar to combined footings. In strap footings, the foundations under the columns is built individually and connected by a strap beam. Generally, when the edge of the footings cannot be extended beyond the property line, the exterior footing is connected by a strap beam with interior footings. Next, we have raft or mat foundations. Raft or mat foundations are used where other shallow foundations such as pile are not suitable. It is also recommended for situations where the bearing capacity of the soil is inadequate. These foundations also should not be used where the groundwater table is above the bearing capacity of the soil. Proceed to the deep foundations. The first one is pile foundations. Pile foundations is driven into the ground with a pile driver, and it can be wood, steel, concrete, or even those combinations. There are two types of pile foundations. First one is friction pile, and the second one is end bearing pile. According to the picture given, friction pile are driven into the ground, but it will not reach the bearing stratum. It is only for the component soil, such as silty, clay, or even sandy soils. But the end bearing pile, the end will hit the bearing stratum, and it can reach down into the depth of 150 feet or more. Next, caissons. It is a hole drilled deep into the ground and filled with concrete. It can range anywhere between from 18 inches to the 8 feet. There are two types of caissons. The first one is bell caissons. The bell caisson spells out at the end of the shape, and it is only used for cursive soils like clay, so it can retain its shape when the concrete is poured down. It must not have groundwater under the caissons. Next is socket caissons. For socket caissons, it will penetrate down deep into the ground until it reaches rock bottom, and it has bearing capacity from its end bearing as well as the friction from the soil. I guess that's all from us. Thank you again for listening to our video. Hope you guys enjoy it. Thank you.